Today we're going to be discussing solving quadratic equations using two different methods. The first method that we're going to use is by factoring, which you guys are already familiar with. We have already done this, so this will be a review for you. The second method will be by graphing, so using our graphing calculator. And that might be new for you. And then the next time we're going to talk about two more ways that we'll solve quadratic equations. And so let's get started. The first method is by factoring. So we have to remember our factoring skills. So first thing that we have to remember about solving quadratic equations is you have to make sure that your equation is set equal to 0. That is the most important thing when we talk about solving quadratic equations. Everything has to be on one side together. Okay, so if you look at A, everything is already on one side. It is already set equal to 0. The next thing that you want to make sure, especially for solving by factoring, is that you want it in a certain way. So you want it in the form, you want it in ax squared plus bx plus c equals 0 form. The reason you want it in this form is because this is how we recognize factoring. Other than a few other special cases like difference of squares or the sum or difference of cubes. But other than that, we want it in this form. So the first thing that we're going to do is make sure that it's set equal to 0. So part A is already set equal to 0. So we're ready to go. All you're going to do is factor it. So remember, you are breaking down the factors of 6 that add to -5. What times what gives me 6 that adds to -5? And the answer to that is -3 and -2. -3 plus -2 is -5. -3 times -2 is 6. So now what we're going to do is take each individual equation now and set it equal to 0. So I'm solving like two miniature equations. X minus 3 equals 0 is one. X minus 2 equals 0 is the other. And from there, you should get two answers. So if you look here, if I move add 3, my first answer is x equals 3. My second answer, add 2, is x equals 2. And those are my two answers to this part A, find all the solutions. On part B, we have a little bit more steps. First off, this is not set equal to 0, so we're going to have to fix that by moving the 9 over. But before I move the 9 over, notice this is not in the form that we wanted in, ax squared plus bx plus c. So what I'm going to do is I'm actually going to multiply x plus 3 times x plus 3, right? I have two of them, so x plus 3 times x plus 3. So I'm going to FOIL that together and get x squared plus 3x plus 3x plus 9 equals 9. I'm going to combine like terms. X squared plus 6x. Now, I'm going to go ahead and I'm going to move my 9 over. 9 minus 9 is 0. So you can put plus 0, but it's not necessary. And now, if you look, I have my equation in the correct form, and I also have it set equal to 0. So from this point, what I'm going to be able to do is factor. Now, since this only has two terms, all I'm going to do is take out the greatest common factor, So they both have an x in common. I'm going to pull that to the front and write what's left. X plus 6. And that is all I'm going to do on that one. I'm going to take each equation and set it equal to 0. So I've got x equals 0 and x plus 6 equals 0. Don't forget about this x in front. Just because he doesn't look like this one does not mean that you still don't have to take it and set it equal to 0. That means that I have a 0 or a solution at x equals 0. And then my other one, when I subtract 6, is going to be x equals negative 6. And there are your two solutions. On the next one, now we are going to do an example where you solve by graphing. So you're going to use the graphing calculator. Now the reason you would want to do this instead of factoring would be, number one, you can always use it to check your work. So if you have to do it using algebra, one of the 3 other ways that you're going to learn, you can always double check yourself using this equation, using this calculator method. Also, if it doesn't factor, that would be a good indicator that you can use your graphing calculator instead. So go ahead, make sure you have your graphing calculator out. You still have to follow the format. Like, you want to make sure that everything is set equal to 0. So I'm going to move the 15 over. Before you can type it in your calculator, everything has to be set equal to 0. The equation does. So there's what I'm going to type in. And if you notice down here, it says enter the equation. So you're going to go y equals, type the equation into y1, hit graph, and then notice solution is also the same thing as 0. So we're going to do, you're going to follow second, calculate, and then you're going to choose option 2 that says 0. So what you're doing is you're finding the zeros, you're finding the solutions, the 2 places where it crosses the x-axis. Okay, now it's going to pop up that left bound, right bound screen. Now when you're finding this root right here, up here somewhere is your left bound. So you need to make sure you're above the graph on that one. Down here below the graph, or below the x-axis, is your right bound. So you'll hit, go left bound somewhere up here, hit enter, drop a pin down, then scroll down, go below the below the x-axis, hit enter, drop a pin down, and then hit enter one more time to guess. And it's going to tell you the root, x equals negative 5. So I know one of my solutions is x equals negative 5. You're going to do it again for the other root, because there's 2 of them, remember? So you're going to go, you'll do it again. You follow this again. Second, calculate, choose option 2, 0. And then now on this one, your left bound is below the x-axis. So you'll want to stay underneath for left bound, hit enter and drop a pin down, and then scroll up above the graph somewhere, above the x-axis. That's your right bound. Drop a pin down and then hit enter to guess, and this will be your other solution. Okay, so this helps you know how to double check your work, especially on your factoring ones. If you're not real confident in factoring, but I ask you to do it the factoring way, you could always double check your work on the calculator and make sure you factored it correctly. So that is how you're going to use the calculator feature. So we're going to do another example, part B, of using the calculator. So again, you have to set the equation, set equal to 0. It's not set equal to 0, so we're going to move everything to one side. So we're going to say x squared. I'm going to move this over and move this over, so I'm going to change the signs. So plus 3.35x minus 12.995 equals 0. Now you're going to go to y equals and type the equation in and follow the directions like you did up here for this one. So you're going to choose second, calculate. You do second, calculate, choose option 2 where it says 0. Okay, you're going to do the left bound, right bound, and you're going to get one solution of x equals negative 5.65. Then you're going to do this process again. So go back, second, calculate, option 2, 0, and do it again. Left bound, right bound. Hit enter to guess, and you're going to get another solution of 2.3. So these are the two places where I have solutions, x-intercepts, zeros. All of those words are all interchangeable with each other. Now we need to do a word problem. So if you look here, we've got a frog that hops, and they give us the equation right here for the frog and the path that it follows when it hops or jumps. Part A says, how far did the frog jump? So first off, let's think about this. So let's go back up to our original graph. Now, how far does the frog hop? That is going to be how far along the x-axis until he hits the ground again. So we're wanting this point right here. Okay, so when it says how far did the frog jump, that's what we're after, is this point right here, which we just learned is called a 0. So we can follow what we just learned on the calculator, plug in the equation into y equals. Now, you're going to have to adjust your window because since we're talking about a real world problem, most likely your windows are going to be, I'm going to write window so you know you have to adjust your window. So my x min, if you will go in and change that to 0, then that will set this to where we only see from here on. And then x max, for the sake of this problem, it will be different for every other problem you do, but for the sake of this problem, set it to 30. Now your y min, same thing. You know, we don't have like negative distance, so we're going to start it with 0 and see how high up he goes. So in your y max, you can leave it at 10. So if you'll adjust your window, you'll be able to see this parabolic curve a little better. So you're going to type in the equation into y equals. And so notice it says nothing past this point has real world meaning. So that's why we don't include any negatives this way or any negatives this way. We only have from where he took off, following the path of his motion down to where he lands on the ground. Unless he lands in a hole, you're not going negative. So what your goal is, you're going to try to find this 0 right here. So you're going to do the left bound, right bound thing. So go second, calculate, option 2, 0. And then remember on the curve like this is your left bound. So I'm going to put an L. This is your right bound. Drop your pins down and guess. And it's going to give you 20.34. So that is how far the distance that he traveled in one jump. 20.34 feet. Now, part B says, how high did the frog jump? So this one, what we're going to do is you say second, calculate. We want to choose the maximum. So option 4, max. Because what we're wanting to know is this peak right here. How high did he go up off the ground? Okay, so when you do that, you're going to do the left bound, right bound thing again. So over here is your left bound. Over here is your right bound somewhere. I mean, it doesn't matter as long as you're on either side of the peak. Drop your pins down, and it will guess, and it's going to give us 10.17 and 3. So hopefully you get that as well. Now, which one of these is my actual max? Because the ordered pair is the max. However, when it's saying how high did the frog jump, what it is wanting is it's wanting the y value, the y only. All 10.17 tells us is that is the point that he traveled on the x-axis in feet to where he reached the peak. So we don't really want him, we only want the y value. So my maximum, or how high did the frog jump, is 3 feet. The last part says, what is a reasonable domain and range for such a frog jumping function? So that's the way that we adjusted our window actually helps us to kind of identify the domain and range. Now remember, let's go back up here to the bigger picture. Domain is all the x values. So if we're looking at domain, again, we're looking along the x-axis. It starts at 0 and stops at 20.34. So if I'm saying my domain, I'm probably going to say a reasonable domain, because you don't have to be exact, would be 0 to 21. I just rounded up to 21. You can put, 25. I mean, there's you have a little bit of freedom here because it says reasonable. So there's a lot of reasonable answers, but we're just going to say 0 to 21. Now my range, so these are the y values. I'm going to go back up so you can see the picture again. Your range are going to be, how high up did he go? What would be a reasonable range for that? So we know at the peak he reached 3 feet. So 0 all the way up to 3 feet would be a reasonable range. So you can put 0 to 3. You could say 0 to 5. I mean, there's a lot of reasonable answers. These seem to make the most sense because we're kind of narrowing it into where we're close enough. So that is going to be how you will work your word problems. Use your calculator, adjust your windows to fit the problem, and you can use your features on your calculator we just talked about to solve for those. And that takes care of 2 of the methods in which we solve quadratic equations.